In this video, I'm going to show you how to recode the health variable and one of the religion variables. There are many reasons why you might want to do this, but one reason is that you might want to transform a variable with multiple categories into a binary variable for use in a binary logistic regression. Also, you might want to transform a more complicated multi-category variable into something a little bit shorter for use as an independent variable. We'll look at both examples here today. The variable that we're going to look at first is the health variable. And you'll see there's a variable in the European Social Survey that asks people to rate their subjective general health. It's on line 121 and the variable name is health. And you see here the variable is coded into, we've got 5 valid categories. First of all, we've got very good, good, fair, bad, very bad. And we've got 7, 8 and 9, which is refusal, don't know, no answer, coded as missing. So if we were to run a frequency table on this, we would see that our table would have 5 categories. We would get that little ranking variable there displayed with a percentage in each of the 5. So let's say we wanted to produce a model that predicted a subject's subjective general health. This is, as we can see, is not a scale variable, and there are more advanced methods for dealing with ordinal dependent variables that we haven't covered in the introductory courses. So let's imagine that we want to look at a binary logistic regression that's trying to predict whether a respondent is in good health or higher or not. And what we're going to do here then is to recode the categories very good and good into one category, which we'll call good or above, and another category which includes these categories 3, 4 and 5, fair, bad, very bad. And if you want to have a look and see what the categories of the variable are, you can go into reports and codebook and you can inspect the variable yourself to see some more detailed information about it. So if we transfer this over here, you'll see that the codebook gives us the values attributed to each of these categories. And these are important because now when we go to transform the variable, we're going to need to know what each of these different numbers refers to, which category they're associated with. There are 2 ways to do this. We can, first of all, by going into transform, we can either recode into the same variable, in which case it will alter the existing variable and replace it with whatever new coding scheme you select, or we can recode into different variables. And I'm going to use this one because it's always a good idea to retain the original variable in case you need to go back to it or recover some of the information in it. We click recode into different variables. You'll see here that again this setup should be becoming quite familiar to you. We have our original list of variables over here on the left, and we'll transfer our health variable over here into our output variable. There's a few things we need to do. We're going to need to give the output variable is going to generate a new variable with the name we insert in here and the label we insert in here. So I'm going to first of all click on old and new values. And this is where we're going to tell SPSS which value corresponds to which in the new scheme. There's a few ways we can do this. We can do this one by one. We can simply go through each of these categories and say that now category 1 is going to remain category 1. Category 2 is going to become category 1. Category 3, 4 and 5 will now become category 0. And what we will end up with is a new variable where category 1 is individuals in very good or good health, and category 0 is individuals in fair, bad or very bad health. So you'll see here that if we put number 1 here into this old value and number 1 into new value and click add, we see that the transformation it's going to apply, it's not going to change that category at all. The old category 1 is going to remain category 1. And again, we want those individuals who report good health to be in the 1 category when we go on to use that variable later on. For category 2 then, we are also going to want to code this to 1. Because again, we want to collapse both of these groups into 1 category of good health. Now, the other way to do this is we can also specify a range, and this is useful if we've got a number of different values that are going to become the same in the new coding scheme. In this case, we want 3, 4 and 5 to become category 0. We can do this individually. We can type old value 3, new value 0, and simply transfer those in one by one, or we can specify a range. In this case, our range will be 3 through 5, and the new value is going to be 0. And this is useful in the case of scale variables as well. If we wanted to recode an income variable taking a particular cutoff, we could specify a value saying, okay, everything and below, or everything from this point and above. So there's a number of ways to do it. The manual way is fine, or the range method is fine if you've got a number of values that you want. So now we have the instructions for the transformation from the old to the new. We click continue, and now we need to give it a name, and we'll just call it health. We'll call it health 2cat, and we'll call it 2 category health. Now you have to click change to apply this, and then OK. And when you go back to your data set, you'll see that down at the very end, what it's given us is this new variable down here, this 2 category health variable. Now the other thing we need to do is to assign values to it, because to make the output legible, we need to know which of the categories is which. So we have 2 in here, value 0, which is poor health and below. And we have category 1, which is good health and above. Or you could, if you want to, abbreviate this to simply poor or good or whatever, and just for legibility we'll change this to 2 decimal places. Now you'll notice something. If we go into our descriptive statistics and we put in our new health variable, and if we examine the output table, you'll see that it gives us a list here of poor health and below, good health and above. We have 78.3 respondents in this one, and we have 21.7 respondents in this one. You'll see also it has retained the missing categories here, and it's still counting these as missing. We had 1 missing category in the original variable as a don't know, and it has retained this as a system missing. So we have here 21.7% of our respondents in poor health, and we have 78.3% of our respondents in good health or above. So now we can use this 2 category variable if we wished in a binary logistic regression. To look at another example, if you were looking at recoding a different type of variable, let's say our education variable. You see there's a number of these. There's one that uses, and some of these use different scales and measures. We've got highest level of education here, which uses this standardized scale. It's quite complicated, and it's not intuitive to us because it doesn't use the original titles that we will be familiar with. There's another standard scale here you'll see here under highest level of education Ireland that does give us the relative educational ranks in the NFQ, that's the National Framework for Qualifications, so our level 6, 7, 8 and so on. If you wanted to recode this into, and again you could recode this or collapse this into as many categories as you wish, but if you wanted to introduce a binary cutoff that simply predicted whether individuals were in let's say level 13 and above, then you could simply repeat the recoding procedure, applying a rule that says that all categories 1 to 12 become a code of 0 and all categories 13 and above get a code of 1. But this also works in the case of ordinal variables. So let's say you have an attitudinal variable, and we'll look at one of these now, which is the religiosity variable. So you'll see here in the survey they've got a number of different measures of religion. They've got specific measures for each country that ask which religious group they belong to, and they've got a measure here that asks how religious are you. And let's say you wanted a variable that split the sample into people who were religious or not religious. And again, this is sort of an oversimplification of the process, but sometimes there are times where we might wish to do this. And there are a couple of indicators you could use. So there's a variable here that asks how religious are you, and we've got this 0 to 10 scale with not at all to very religious. We also have this other one here that asks how often respondents pray and how often they attend religious service. So we could use the attendance variable to identify religious versus non-religious individuals, although in reality we wouldn't be as simplistic about that because religiosity is much more complex than simply a yes or no. But let's say we wanted to define this, or we wanted to recode this, or to identify the religious individuals as those who attend a service at least once per week, and the non-religious as those who attend less often. You see here the variable name is this RLGATND, and we can have a look at this first of all to see, and it's always a good idea to check the distribution. And if we go back up to our original set of questions and move down here to the end, we can see here that we've got our religious variable just down here towards the end. Now if we look at the frequency table here, you'll see that we've got a number of different options in this. We've got more options than we had on the health variable. We've got every day, more than once a week, at least once a month, and so on. There's a comparatively smaller proportion of respondents in the weekly or more category. We see this from the cumulative percentage. So there are 32.3% of respondents attend a service at least once per week. You see this because this 32.3 is the sum of 24.7 plus 5.4 plus 2.2. So let's say we want to apply a cutoff here. It's always a good idea to identify this from the codebook as well. So you can go back and look at the codebook if you wish, and it's always a good idea to start with this. But these are coded 1, 2, 3, 4, 5, 6, and 7. So once we go in, and again you can also check this if you wish in variable view by clicking in here to see what the coding scheme is. And we already have our 77, 88, 99 identified as missing. So if we go into transform, recode into different variables, don't forget if you're doing multiples of these in the same session, you need to hit reset. We're going to display our variable names, and then we'll scroll down to find our religiosity variable, which is over here. And always make sure that you cross-check the names to make sure they're correct. Our old and new values then are going to be, again we'll use the range function to this. We're going to have categories 1 to 3, which are going to be category 1. This is the those regular attendees. And we're going to have categories 4 through 7 as 0. And these are the individuals who attend less frequently. Click continue, and we'll give it a new name, and we'll give it something that's fairly close to the old one. And we'll call it 2 category attendance. Always click change and then OK. And when we click back to our data set, you'll see that at the end it has again given us a new variable, which is this 2 category attendance one. Don't forget we need to specify the number of categories. Change the decimal precision to 0. And our category 1 is going to be weekly or more. And category 0 is going to be less. So again, now when we go into our frequency tables, we should have a 2 category variable that simply reports the percentage in each of those 2 groups. So now we can use this variable in our binary logistic regression if we wish. We could also use it as an independent variable in another form of regression. So this is the basic procedure for recoding variables for use as either dependent in a binary or independent variables in another form of regression. Again, these will work in either the linear regression or logistic regression.